Hi everyone, this is my video of the solutions to the practice test. I suggest that you do the practice test yourself, and for the questions that you don't understand, fast forward the video to that problem and watch the solution. Okay, starting with number 1. We have a problem where we are adding and subtracting integers. We will start left to right. So the first thing we need to do is find out what 9 minus 5 is. Well, 9 minus 5 is 4. And I continue to write out the rest to make sure that I don't lose track. The next problem is 4 plus negative 8. So if we're adding a negative, we're actually subtracting. So 4 plus negative 8 gives us negative 4. And finally, negative 4 minus 4 gives us negative 8. And our answer is negative 8. Next problem. It says evaluate the expression 5.8 plus 1.34 minus 6.21. We're adding and subtracting decimals. And just like the last problem, we'll work left to right, starting with 5.8 plus 1.34. Because we can't use a calculator, I'm going to write this vertically and look like something like this. So 5.8 over 1 plus 1.34. Make sure you line up the decimals and add zeros as placeholders. Okay, so in the hundreds column, so 0 plus 4 is 4. 8 plus 3 is 11. Place the 1. And then 5 plus 1 is 6. Add the extra 1 is 7. So 5.8 plus 1.34 is 7.14. I'm going to write that down under my equation. 7.14 minus 6.21. And we'll do the final subtraction. 7.14 minus 6.21. And 4 minus 1 is 3. 1 minus 2, well, we can't do 1 minus 2, but what we can do is we can borrow from the 7, put a 6 there, put a 1 there. So now we have 11 minus 2. That's 9. And now we have 6 minus 6, which is 0. And so our final answer is 0.93. Next, it says evaluate the expression 24.5 times 0.41. Let's work through this. So I'm going to write it out vertically. 24.5 times 0.41. Okay, so a key difference when we're multiplying is that we don't need to line up the decimals. We don't need to line up the decimals, but we do need to pay attention to how many decimal spaces there are. So in this case, there's 1 decimal space there. It's at 5 of 24.5, and there are 2 decimal spaces here. It's the 4 and 1 from 0.41. So it's important that we just take note of the number of decimal places. There are 3 places. Okay, we're going to use that later. Now we want to do this multiplication without worrying about the decimals. And we'll start with 1 times 5. So 1 times 5 is 5. 1 times 4, 4. 1 times 2 is 2. And then we place a 0 because we're moving over to the 4. We're multiplying everything by 4. So 4 times 5 is 20. Place the 0. 4 times 4 is 16, plus the 2 is 18. And then 4 times 2 is 8, plus the 1 is 9. And now we need to add up these two numbers. 5 plus 0 is 5, 4 plus 0 is 4, 2 plus 8 is 10, so I place my 0, move the 1 above the 9, and then 1 plus 9 is 10. So we're almost there. Our very last piece, it's these 3 decimal places that we count. We need to add all 3 decimal places back into our final answer, and we'll place our decimal. So 1, 2, 3 places in. And our final answer is 10.045. Next, okay, expanding and simplifying expressions. Expand really just means to multiply. Simplify suggests that we combine any like terms. So let's take a look at, we have -4 times the binomial y minus 6. Because there's a variable in the binomial, we're always going to end up with 2 terms. Okay, so we're never going to get rid of those 2 terms. We'll still have 2 terms, but we do need to use our distributive rule and multiply that -4 with each term inside the brackets. So I like to draw my rainbow in this case, so it'll be -4 times y plus -4 times -6. So here we go. Let's see. -4 times y, and then plus -4 times 6. Oh, no. You know what? I need to be really careful here. So I like to always make this adding, but when I do that, I need to make sure that I take the sign in front of the 6 when I'm doing my multiplication. So instead of -4 times 6, this is actually -4 times -6. And I'm going to add some brackets just so we're really clear where our negative numbers are. So we have -4 times y, which is simply -4y, plus -4 times -6. Well, when we multiply 2 negative numbers, we get a positive number. So -4 times -6 is 4 times 6, which is 24, and the sign turns positive, so it's 24. And we have -4y plus 24. Okay, let's move on to the next one. So we now do this. We do the same thing. We have a monomial times a binomial. So -3a is a monomial, and 2b plus 5 is a binomial. We use our distributive rule again. We get -3a times 2b and -3a times positive 5. Let's write it out. -3a, put it in brackets, times 2b plus -3a times 5. Okay, -3a times 2b, so we're just multiplying. We first are multiplying that -3 times 2. You know what I'm going to do? I'm just going to reorder everything. So it's important to know that when we're multiplying these 2 terms, we can multiply the coefficients, which is that -3 and -2. And we'll get -6. And we don't know the values of a and b, but they don't go away. They're still there. So -3a is -3 times a, and 2b is 2 times b. We're just reordering things, really. But the a and the b remain, and we get negative 6ab. And that term negative 6ab is just negative 6 times a times b. And the a and the b don't go away. We'll do the same thing with the next term. So plus, and again, we take that coefficient, negative 3, multiply it by the 5, and we get negative 15. And the a is there, the a remains. We get negative 15 times a. Okay, so this is a perfectly acceptable answer. So this answer we see here is perfectly acceptable. Maybe you'd have a set of brackets around that negative 15a. But if you remember, if you're adding a negative number, it is the same as subtracting a positive number. So we can rewrite our answer as well to negative 6ab minus 15a. Okay, both of those answers are perfectly acceptable. I will accept both. You'll get a right answer for each. And those are our answers. Let's try the next one. It says simplify the following expressions. Here we're really just looking for like terms. We want to combine our like terms. It's really helpful in this case to underline the like terms, make sure we're aware of which ones are like terms. So if we remember, our rule for like terms is that they are terms that have the same variable with the same exponent on it. And in the first example, a, they're all like terms. So we have 7y, the variable is y. We have negative 3y, variable is y. And we have 5y, variable again is y. And so we can add or subtract all of these, starting with the first two. So 7y minus 3y leaves us with 4y. I'm just going to write out 5y so I don't lose track. And then 4y plus 5y is 9y. And our final answer is 9y. Let's move on to the next one. Here we have a whole bunch of different terms. And yeah, so they're not all like terms, but some of them are. So let's keep track of those like terms. So it's the same variable with the same exponents. And there can even be two variables. If there's two variables, we need both variables for them to be like terms. And in this case, 3ab and negative 7ab are like terms. We have some other like terms, so this negative 2a and plus 5a, those are like terms. And then 4a squared doesn't have any like terms, but so it's just going to stay there. It's just going to be 4a squared. But let's reorder this so it's easier to do the math. We're going to push all the like terms together. So like terms are 3ab, and I'm going to take this whole, so minus 7ab, and move it. So don't forget to take the sign in front of the 7ab. So 3ab minus 7ab, and then we'll move around the other ones. So our other like terms are minus 2a. Again, I'm taking the sign in front of the 2a, plus 5a, and then plus 4a squared. Now we have to combine our like terms. Okay, we have like terms there. We have like terms here. So starting from the first set, 3ab minus 7ab leaves us with negative 4ab. Then negative 2a or minus 2a plus 5a leaves us with positive or plus 3a. And then we have our 4a squared still. And we're done. That's our answer. negative 4ab plus 3a plus 4a squared. Just resist the urge to do anything more here. Because we don't have any like terms, we can't simplify it any further. So you are done. Next problem, solving equations and substitution. This is a good one. When we're substituting, it just means, or when we're solving equations, we're really just trying to isolate our variable and determine what it equals. And we can use our algebra skills for this. We're going to rearrange our equation so that k is on one side all by itself. So the first thing I'm going to do is I'm going to try to isolate 3k. So the first thing we'll do is try to make 3k on one side all by itself. And I do that by moving the 9 over. And the way we move the 9 is by adding 9 to the left side. And whatever I do to the left side, I also have to do to the right side. So I'm adding 9 to both sides. And I have 3k. But then I have that minus 9 plus 9, which just equals 0. And they cancel each other out. And that equals 6 plus 9 on the other side, which is 15. So I'm left with 3k is equal to 15. Now I'm trying to isolate the k all by itself, meaning I want to get rid of the 3 in front of the k. And so I divide it away. Divide by 3. Divide by 3. So if I divide 3k by 3, I'm left with 1k, or just k. So these things cancel each other out. So 3 divided by 3 is just 1. So I'm left, I can leave the k there. And it equals 15 divided by 3, which is 5. And my final answer is k is equal to 5. We figured out what k equals. Okay, the next one says graph the inequality. And our inequality is x is greater than or equal to 4. So if we remember from our lesson, whenever we have a greater than or equal sign, or whenever we have a less than or equal sign, you know what, I'm going to just write this beside it. So greater than or equal, or less than or equal, we use a closed circle, so a circle that we fill in. Okay, and whenever we have greater than or less than, we use an open circle. And so I'll show this on the number line. So x is greater than or equal to 4. I'm going to go find the 4, which is here. I'm going to, above the 4, I'm going to draw a closed circle, or a circle, and then fill it in. There we go. And greater than or equal to 4 points in the greater direction. I'll draw an arrow in the greater direction. And it looks like that. That's the final answer. Okay, the next problem, number 9. I don't know, we skipped number 8 for some reason. I'm not sure why that happened. But let's move on to number 9. It says 3 times a number decreased by 4 is 11. 3 times a number decreased by 4 is 11. It says let n equal the number. So the let statement is created for us. If this statement wasn't created for us, we'd have to create one. Okay? But this q, so 3 times a number decreased by 4 is 11. But, well, times means multiply. So whenever we see times, this means multiply. And decreased means subtract. And then is suggests equals. So let's see what we can create in terms of an equation. So n is our number, and it says 3 times a number, so our equation would be 3 times n decreased by 4. So this number 3n decreased by 4 minus 4 is 11. So equals 11. So that is our equation, but now we have to solve it. So in order to solve it, we'll balance our equation, but what we're really trying to do is this first step, isolate 3n. So we want 3n on the one side all by itself. In order to do that, I'm going to add 4 to both sides. So it means now on the left side I have 3n minus 4 plus 4. Well, the minus 4 plus 4 cancel each other out. It's kind of like saying I have negative 4 and then I'm going to add 4. Well, now I have 0. Okay? And I'm left with 3n on the left side is equal to 11 plus 4 on the right side, which is 15. Now we want to isolate n further, so make n all by itself and remove the 3 in front of the n. We do that by dividing it away, divide it away. So, and this cancels out the 3. We're left with n equals 5. Okay, and the number is 5. We'll just write that out. The number is 5. Okay, let's go to problem number 10. Okay, this is a longer problem. It's a multi-step expression that we have to evaluate. They're all numbers, there's no variables. We can find a final answer here. Evaluate means just find the final answer. But we need to use BEDMAS. Let's write it out. So BEDMAS, brackets, exponents, division, multiplication, addition, and subtraction. If we remember division and multiplication, they're actually ranked the same in BEDMAS as our addition and subtraction. They're also ranked the same. But the first thing we need to do when we're using BEDMAS is evaluate whatever's in the brackets. So let's do that. It's this 4.8 minus 1.3 that we need to deal with first. I'm going to write this out again. 3, and we have to evaluate the brackets, plus 4 squared. I'm just going to try to take note. Brackets. Well, these are decimals. So I'm just going to do it here. 4.8 minus 1.3. Carry my decimal down. 4 minus 1 is 3. And inside the brackets, we get 3.5. Next, so after brackets, we need to evaluate the exponents. And the exponent here, in this case, is this 4 squared. I'm going to write everything else out so I don't lose track. So 3 times 3.5 plus 4 squared is now 16. So 4 times 4 is 16. So 4 squared is 16. Okay, next, let's see, there's multiplication here. So 3, and then the brackets, 3.5. That's 3 times 3.5. So we're doing the multiplication. 3 times 3.5. Well, let's just write it out here. 3.5 times 3. We have 1 space. So 1 space, which we'll have to add in at the end. But when I'm doing this calculation, I have 3 times 5, which is 15. So I put the 5 there and the 1 up. 3 times 3 is 9. Well, 9 plus 1 gives us 10. And we get 105. I'm going to put that space, okay, and add the decimal. And so our answer is 10.5 to that. So 3 times 3.5 is 10.5. And we still have this plus 16. And in order to get the final answer, we need to do addition here. Addition, The addition is 10.5 plus 16. So we're careful when we're adding. So remember, when we're multiplying, we don't need to line up the decimals, but when we're adding, we do. So 10.5 plus 16.0. 5 plus 0 is 5. Okay, we carry the decimal down. 0 plus 6 is 6. 1 plus 1 is 2. And our final answer is 26.5. 26.5. Okay, let's do the next one. Ooh, so here we have a series of positive and negative numbers. There's some multiplication and there is some addition and subtraction. So we're first going to deal with the multiplication. Multiplication. So the multiplication is this 5 times negative 4 and negative 2 times 9. Let's do it. 5 times 4 is 20. So there's one negative sign between the two of them. So our final answer will be negative. So 5 times negative 4 is negative 20. And I'm going to put some brackets in there. Just careful so we can keep track of our integers. Then we have minus. And then negative 2 times 9. Well, 2 times 9 is 18. Okay, we have negative 2 times positive 9, meaning there's one negative number, and our final answer is also going to be negative. So we have negative 18. And I'm just going to write the plus 6 so I don't lose track. Next, we have addition and subtraction. And we move left to right, starting with this negative 20 minus negative 18. Well, I like to turn everything to addition. And negative 20 minus negative 18, if we're subtracting a negative number, it's like adding that number. So we would have negative 20, and I'm going to just write this out so we all see it. So minus a negative number is like adding. And so we have negative 20 plus 18 plus 6. Well, that negative 20 plus 18 gives us negative 2 plus 6 still. And then negative 2 plus 6 leaves us with positive 4. And our final answer is 4. Next. Number 11, it says solve for x, show your steps for full credit. Ooh, there's a couple ways we can do this one. I'll do it both ways. So I'll write this out again. 3 times 2x minus 5 plus 8 equals 17. The first way we went over in class was to first evaluate this. Okay, this 3 times 2x minus 5 using the distributive rule. So we can evaluate that like this. And 3 times 2x gives us 6x. And 3 times negative 5 gives us negative 15, and we get 6x minus 15. We still have the plus 8 equals 17. Okay, we now have these two constants. We can simplify this. So to do that, minus 15 or negative 15 plus 8, and we get 6x minus 7 equals 17. So 6x minus 7 is equal to 17. Now we solve it just like we were doing before. We want to isolate this term, so have that term on one side all by itself. We do that by adding 7 to both sides. So these two numbers cancel each other out. We're left with 6x is equal to, 17 plus 7 is 24. We now isolate the x. We want to remove the 6 in front of the x. We divide it away. And so these 6 divided by 6 just turns into 1. We're left with 1x, or just x, is equal to 24 divided by 6, which is 4. And x equals 4 is our final answer. Good. Now that was the first method. The other method is to just get closer and closer to isolating x by itself on one side. And so the first thing we want to do is isolate the set of brackets that x is in. Isolate the set of brackets that x is in. And so the first thing we will do is we will remove this plus 8. So we'll subtract 8 from both sides. And what we get is we still have this 3 times 2x minus 5. But this plus 8 minus 8 cancel each other out. And we're left with 17 minus 8 on the other side. Well, that is 9. Next step would be to, again, we're trying to isolate those brackets, 2x minus 5. Make the 2x minus 5 on one side all by itself. So we get rid of the 3 by dividing it away. So we divide this whole thing by 3. And because we do that, we have to divide the other side by 3. Well, this 3 and 3, they cancel each other out. So 3 divided by 3 is equal to 1. Leaves us with 1 times 2x minus 5, which 1 times anything is just itself. So it leaves us with 2x minus 5 on one side equals, well, 9 divided by 3 is 3. And now we're trying to isolate the 2x. So we add 5 to both sides, and we are left with 2x is equal to 3 plus 5, which is 8. And we'll keep going. Now we divide both sides by 2. Divide by 2. These cancel out. We're left with x is equal to 8 divided by 2, which is 4. So either way, we get the same answer. But done 2 different ways. Use whatever method is most comfortable for you. Next, we have a bit of a word problem. Number 12, it says, a total bill at a restaurant was $45.50, which needs to be split equally among 7 friends. How much money does each friend need to pay? Well, we would just divide that value by 7. We'd break it up in 7. So we do need to be able to divide this decimal. So let's do that. So 7 divided by, $45.50 divided by 7. We can write it out like that. So let's see, we start off just, how many times does 7 go into 4? Well, it doesn't go into 4 any times, so 0. How many times does 7 go into 45? Well, it goes into 45 6 times. 6 times 7 is 42. So 45 minus 42 leaves us with 3. And we'll bring down the 5. And we'll bring up the decimal point. Now, how many times does 7 go into 35? It goes evenly 5 times into 35. So 5 times 7 is 35, and we're left with 0. And so 7 goes into 4550 6.5 times, which really means that each friend has to pay $6.50. So each friend has to pay $6.50. $2.50. Don't forget this final statement. It's this final statement. That is your final answer. Okay. Next one, it's a fencing problem. So a builder needs to use 150 meters of cable. All these numbers always seem to be so important. So builder needs to use 150 meters of cable to run electrical lines to two different parts of the building. One section needs to be twice as long as the other. So this 150 meters needs to be broken up into two, because it's going to two different parts of the building, and one section of these two pieces needs to be twice as long as the other. Okay, so two different parts. So one section needs to be twice as long. One section, twice as long. It says create an equation that represents this situation. Make sure you define your variables using let statements. So let's do that. So we've got two pieces, different lengths. We'll say let x be the length of the short piece. And the other section is twice as long as the short piece, so let 2x be the length of the long piece. Okay, now we have to create an equation. So we have 150 meters of cable, which has been broken into the two pieces, the short piece and the long piece. So we could say the short piece, x, plus the long piece, 2x, is equal to 150, or 150 meters. Well, we have like terms x and 2x. They're the same variable with the same exponent. We have 1x plus 2x gives us 3x is equal to 150. Okay, good. Now, it says using your equation, determine how long each section of cable will be. Make sure you clearly state how long both of the cables will be. Well, let's isolate x here. So we have 3x is equal to 150. If we find x, we find the length of the short piece. So isolate x by dividing away the 3. And we get x is equal to 50. Okay, or 50 meters. So that's one. So the other, if the short piece is 50, the long piece is 2x. So we will sub sub x is equal to 50, meaning substitute x is equal to 50 into our equation, and we get 2 times 50 is equal to 100. And we can say the short piece of cable is 50 meters long. The long piece is 100 meters long. Final answer. Okay, we'll look at our final problem. For some reason, this final problem wasn't showing up, but I added another one, which we'll solve together. It's an inequality. We need to solve for y. And let's take a look. So the first step always in these is to move the variables all to one side. So let's move this minus y over. Okay, we'll move that over by adding y to both sides, or adding 1y to both sides. Plus y, plus y. And now this negative 8y plus y leaves us with negative 7y plus 32 is less than or equal to negative 17. Let's now isolate this negative 7y. We'll do that by subtracting away the 32. We'll do that to both sides. We are left with negative 7y is less than or equal to, well, negative 17 minus 32. That leaves us with negative 49. All right, now we need to isolate the y, meaning get rid of that negative 7 in front of the y. We do that by dividing it away. Divide by negative 7. Divide by negative 7 from both sides. If we remember from class, from our lesson and inequalities, whenever we multiply both sides by a negative number or divide both sides by a negative number, we need to switch the inequality sign, which just means turn it around. So in this case, we know this negative 7 divided by negative 7, they just cancel each other out. We're left with y on one side, y. But we have to switch the sign now because we divided by a negative. And we'll finish it off with the division of negative 49 divided by negative 7, which is, let's see, a negative divided by a negative gives us a positive. And 49 divided by 7 is just 7. So y is greater than or equal to 7 is our final answer. Well, a greater than or equal sign, that is a closed circle. We'll draw a closed circle above 7, just like that. And then y is greater than or equal to 7, so we'll draw an arrow in the greater than 7 direction. And that's our final answer. If you do have any, if you watch the video, you have any questions, please come visit me during tutorial, or just show up at the math office and you can ask one of the math teachers any questions.